Okay, so let's just now go through an example of a reconnaissance process and make connections to the tools that can be used for that. Okay, just to give you an idea about how it normally happens. So we will not mention any specific client here, but let's say it's something that has a very broad bug bounty program scope, like Yahoo or Google or Facebook or something like that. So there is a lot of to be done, and you certainly have to automate. And this is how you do it. So on the passive reconnaissance side, we have some steps, and on the active reconnaissance side, we have also some steps, and we see this mention of feeding the data back and forth. This means that, yeah, this is a circle. These are two circles, and they repeat themselves many times before we are satisfied with the results. And at any point of these circles, at any step, we can fall back to another step of another circle. Okay, so it can be interconnected in many ways. So you'd rather imagine this as a full mesh network of these nodes. Okay, so let's start with the passive reconnaissance step 1. We map the scope of the client, so we use Maltego to dig into some basic information about what the network properties are, what's the presence in terms of DNS names, yeah, so what's the mix record, what's the NS record, what is 3W record, what is the list of popular DNS names within that domain, and what are the IP addresses of those host names, right? So if it's relatively small, we'll use Maltego. If it's large, we will use Recon-ng. We will use Google Dorks, Google Hacking database as well, because we'll have to find as much data linked in the Google caches as well. So we will use that in circles for many times when we finally have come to a situation that, okay, we will have found every piece of data, and nothing links to anything else that can be of interest. Okay, so at that point we will take the domains and try to brute force. Okay, so we will just try to run fierce against the lists of domain names in order to resolve them and to see that, yeah, they exist and they fall down into this domain of the client we have. And we'll use dig to try to zone transfer or to try to find another records like txt records or additional hosts or whatever. So we will play around with that, and we will browse through websites through FTP sites that we have accessible, right? So we will try different protocols against the host names we have found, and after that we most probably will go to the active phase and try to identify more hosts that are the neighbors to the hosts we already have. Okay, so let's say we have 20 different host names, and they resolve to 20 IP addresses, and we see that some network prefixes can be seen more often than others, and we will generalize over that and say that what if the client just is the owner of the network, right? And we will extend the network to its natural boundaries, like the class C network or /22 network or whatever we see from these 20 addresses, right? And we will do a map minus -sn, right, to just ping every host in this network and see what's up. And if anything is up, and most probably there will be some running hosts, we will see that they back resolve to something that belongs to this domain name as well, and so on. So we will do that. But returning to the passive reconnaissance walkthrough, we will do some social media searching, right? So we'll see who are the employees, how they are interconnected. We'll create probably this Excel spreadsheet that contains all this information. And we will try to automate that as well. So there is this little script called the harvester. It can find a lot of openly available information as emails that are registered in some internet databases or just left on the web pages, and the usernames and the host names and the IP addresses and so on. So this can be a good start too. With that, we will go back filling the Recon-ng database or multi-view graphs, okay, and we will start transforming the data again and again into something useful. And basically in Multigo at some point we will be able to validate some emails that we have collected by the harvester, for example, or just found online, or constructed from the full names we have on Facebook and LinkedIn, okay? Not many people leave their contacts public on LinkedIn, but still having the principle of naming convention, right, and the full names of many employees, we can and even have to automatically create lists of possible emails. And in Multigo, there is a transform that basically validates that. They go to they just go to the SMTP server and validate each email, and you have this little balloon above each of them that indicates whether the email is valid or not. So in this way you could probably assume some accounts as active and valid and some accounts as invalid or already inactive. A person have left the company, for example, and it correlates with their LinkedIn job history, okay? Then what happens next? We have the websites and we want to dig deeper into those websites. Of course, we can use Google hacking, as I said, but we can automate that and can dig into the metadata. So we use Foca in order to search different search engines for links to the files that could contain metadata. These are PDFs, different Office formats like OpenOffice, Microsoft Office, and so on. And then we can download that, such as we just stumbled upon those files, which is not very possible, but still you can just go by a URL and download the file from a publicly accessible website, right? Not in these amounts, and it could be visible if anyone monitors the logs, but still you could do that. So you download that, you analyze the metadata, and you have some more usernames, you have some software versions, you have some printer names, you have some computer names already, because there are file servers that hold all this stuff before it's published, and so on. Of course, if we missed something, we can go to Whois databases, and by Multigo we can identify some more networks. For example, we can just identify a autonomous system in the internet that the particular network belongs to, and see what other networks belong to this autonomous system, and if that's not the internet service provider, but the autonomous system is owned by our client. So this gives us, as a result, the information about all the networks that have been registered directly to this client. Okay, and as I said, there is a lot of value in validating emails, starting from that you have performed the half of your brute forcing of passwords, because you have the usernames at least already, right? And you will have a valid context database for your further social engineering attacks or attempts of attacks. Okay, so I hope this gives you an idea how much work should be done, but with time you get used to it. You keep up with the tendencies, you keep up with the fashions, but the general idea is very simple. You have to dig deeper, and you have to look very broad into the scope, and to collect as much information as possible is available out there in order to be successful on the next stages. Here I give you some references, okay, just to have an idea how different methodology providers see the process of penetration testing as a whole, and reconnaissance and open source intelligence in particular. And this is what I expect to be very interesting to each one of you. That's first of all hacking database, Google hacking database, currently hosted by exploitdb.com. This is the GitHub repository of sec lists. You definitely should clone it and keep it up to date. This is Maltigo Community Edition. It is essential to start using it right now because, first of all, it's fun, and you never know when you can get a lot of value of it. Foca is interesting as well, but be ready to play with making it work on systems other than Windows. This is Recon-ng. It's extensible, so it's not very frequently updated, but it's extensible. So I recommend just cloning it right now to some other place like GitHub, for example, and playing around with different modules you can add. You can program yourself, or you can get in other repositories and connect to it, because this guy, Landmaster, who has created it and who maintains it, he's very firm in terms of the mainstream modules he adds to the framework. He wants to make it as much flexible as possible, and everything that is very specific or more specific than he imagines appropriate, right, for a framework to have, he just does not accept. So I try to maintain to this repository a few times, but he is really very strict in the rules. So if you have to do something very specific or something very resource consuming, most probably you will have to do it on your own. You can maintain the functionality based on the framework and keep it up to date locally, but still be ready to work on it. And there is this I don't know, maybe that's not a good example, but just to give you an idea of extent of automation that can be achieved in Reconnaissance, please take a look at this sniper tool. It's basically a set of tools, and it's an attempt to make everything very automated from the very beginning to the very end. But as you already may get an idea from what we've discussed till this point, yeah, different particular steps can be automated, that should be automated, but the judgment you cannot automate. So this understanding of possible value of going back in this attack scenario and using the information to get more input data, you cannot teach a machine yet to do that, to judge upon that. So please use it very carefully. Use it in a virtual environment or in a network you own. I mean, really, do not use it on your clients. But still, you can have an idea of level of automation that could be possible if we could program artificial intelligences right now. Okay, so yeah, I think that's it for now. I will have one more little demo of a typical recon process automated by Maltigo and Recon-ng in an additional video, but as to the input information, I think that's it. See you around.